this video, I'm going to demonstrate how to graph an ellipse in the Connect and ALEKS system. So here's our problem. We've been given the equation of an ellipse, and our directions are as follows. We want to identify the center of the ellipse, identify the vertices, identify the endpoints of the minor axis, identify the foci, and then also graph the ellipse. And we are to express numbers in exact simplest form, in other words, no rounding. And our equation is x minus 3 quantity squared divided by 25 plus y plus 4 quantity squared divided by 9 is equal to 1. So first off, if we're not told that this is an ellipse, how do we know that this is elliptical? It's based on the standard form of the elliptical equation. So if both x and y are squared and both of these terms are positive, that's our indication that we're talking about an ellipse. Now, an ellipse versus a circle is going to be based on whether or not our two terms involving x and y have denominators that are different. So the fact that one term has a denominator of 25 and then one term has a denominator of 9 indicates that this is an ellipse rather than a circle specifically. So in this case, we do want to identify all of the key attributes of this graph first, but I would encourage you when you're graphing, even if you're not told to specifically identify attributes, you at least want to identify the attributes in parts A, B, and C before you proceed with graphing, because you're going to find that those attributes are going to be key when it comes to drawing a graph accurately. So we're going to go through and we're going to identify all of these attributes, and then we're going to draw an according graph. Okay, so let's flip over and let's go through this on paper. So as with any graphing situation, ideally we want to graph it on paper first, and then we want to translate that into the homework system. Not only so we get the practice with graphing by hand, but if we make a mistake, this will give us a way to go back and check our work and make sure we know where the mistake was made. So here's our equation. Let's go through all the steps to generate our graph. So first thing we want to determine is what is the orientation of this ellipse going to be. So you may recall the orientation for ellipse, either a horizontal ellipse or a vertical ellipse, in other words, which dimension is longer, is going to be dependent on which of our variables has the larger denominator. So in this case, x has the larger denominator, which means that we're going to have a larger x, a larger horizontal dimension. So the orientation of this ellipse is going to be horizontal. So that means when we graph the ellipse, it's going to be longer horizontally and it's going to be shorter vertically. So our major axis will be horizontal, our minor axis will be vertical. So keep that in the back of your mind as you're finding these attributes. Make sure that they make sense in the context of what we know about how this graph should be shaped based on its orientation. Now, before we start to identify any attributes of the graph, we want to go through and we want to make sure that we identify three key values, A, B, and C. So A and B are going to be based on these two denominators. A squared is always going to be the larger of the two denominators. So in this case, A squared is going to be 25. Therefore, A is going to be the square root of 5, the principal square root, the positive square root, which is going to be 5. Now B squared is going to be 9, therefore B is going to be the principal square root of 9, which is going to be 3. Now our formula for C is based upon A and B, or more specifically A squared and B squared. So C is going to be the square root of A squared minus B squared. Notice when we use our formula here, we have addition in the elliptical equation and we're going to have subtraction in the formula for C. So pay very close attention to that sign, because when we graph a different conic, we're going to have a different sign right here. So I'm going to plug in my values. Now be careful, A is 5, B is 3, but we're talking about A squared and B squared, so 25 and 9. So A squared is going to be 25, and then we're subtracting B squared, which is 9. And then 25 minus 9 is going to be 16. So C is going to be the square root of 16, which is 4. So we have A equals 5, B equals 3, and C equals 4. And we have a horizontal ellipse. Okay, so based on these three values plus the orientation of our graph, that's going to give us all the information we need to find these attributes of our graph. So let's start with our center. Now the center is actually determined from two other values in our equation. They're determined from the numbers that are subtracted from x and subtracted from y. Now remember, in the original standard form for an elliptical equation, it's going to be x minus h squared and then y minus k squared. So subtraction is part of the formula. Therefore, if we're subtracting a number, we're going to think of the number itself as being a positive number. Alternatively, in the case where we have an addition, we're going to think of that as subtraction of a negative number. So the constant involved is going to be negative. So the first coordinate of our center is always going to be the number subtracted from x. So in this case, that's going to be 3. And then the second coordinate of our center is going to be the number subtracted from y, which in this case is -4. So that'll be the center of the ellipse. Now keep in mind, the center is not technically a point that is on the actual graph of the ellipse. The actual graph of the ellipse will be based on the vertices and then the endpoints of the minor axis. However, the center is going to be important because it's going to tell us where we need to start as we generate this graph. So let's add that to our graph now. So our center is at 3, -4, so 3, -1, 2, 3, 4, and I'm going to draw it really small because I know this is not actually a point on the graph. Think of it as a point of reference for generating the points that will actually be on the graph. Okay, so now that we know where the center, the starting point for the graph is, we can find our vertices, our foci, and the endpoints of the minor axis. Now, the vertices and the endpoints of the minor axis will be actually physically on the graph. The center and the foci are going to be points of reference. So these are going to be the two to really focus on in terms of getting an accurate graph. Okay, now the vertices are the endpoints of the major axis. In other words, the longer length of our ellipse from vertex to vertex, that's going to be the longest dimension in our ellipse. And in this case, it's going to be horizontal. So if we visualize what that's going to look like, if this is the center of our ellipse, we have a horizontal longer axis. So from that center, our vertex is to the left, and then our other vertex is to the right. Now, how many units to the left and to the right? That's what A is going to tell us. So if A is 5, what that tells us is that from the center, we need to go 5 units to the left, we need to go 5 units to the right in order to find what each of the vertices coordinates are. So if we were to execute that using a formula, we're going to the left, we're going to the right, which means we're changing our x value. So we are both adding and subtracting 5 from our original x coordinate for our center. And then because we're only moving horizontally, we're going to hold that y coordinate constant. So that ends up in 2 separate pairs of coordinates. So 3 plus 5 is going to give us 8. So 8, -4 will be one vertex. And then 3 minus 5 is going to give us -2. So -2, -4 will be our other vertex. Okay, so again, those are going to be actual points on the graph of the ellipse, so they're going to be the most important points we have so far. So 8, -4, and -2, -4. So 8, -4. I'm going to draw that one bigger because, again, that's actually on the graph. And then -2, -4 as well. Okay, now it's worth checking at this point. Make sure, if you found your vertices algebraically, make sure that when you graph them, these are evenly distributed away from your center. You shouldn't have a shorter distance on one side and a longer distance on the other side. That would be an indication that your vertices are wrong. And make sure you look at the dimensions. It's going to be 5 units in each direction away from your center. Okay, let's skip the foci briefly and let's go to the endpoints of the minor axis. Again, these are going to be the other points that are physically on the graph of this elliptical equation. So the minor axis is going to be the shorter dimension. In this case, that's going to be the vertical axis. So starting from the center, we move vertically B units, in this case 3 units. So we're going to go 3 units above the center, we're going to go 3 units below the center. Now that means we're holding the x coordinate constant and we're only adjusting the y coordinate. So our original y coordinate at -4, we are going to add and subtract whatever our value for B is. And then that's going to give us the locations of these 2 additional points that will be on the ellipse's graph. So again, holding x constant, -4 plus 3 is going to give us -1. and then -4 minus 3 is going to give us -7. So the coordinates of our minor axis endpoints are going to be 3, -1, and then 3, -7. So let's put those on the graph as well. So 3, -1. Again, I'm going to draw it a little bit bigger because this is an actual point on the graph. And then also 3, -7. Now, just as before, make sure everything seems to look right. Again, these need to be evenly distributed away from the center, 3 units above, 3 units below, so that does seem to be consistent with the numbers we have so far. Now, technically speaking, at this point, this gives us enough to actually sketch the graph of the ellipse. So if we connect these points, again, not the center, but the vertices and the endpoints of the minor axis, using a smooth curve, that is going to be the graph of our ellipse. Now that's technically all we need to get an accurate graph, but we were also asked to find the foci, so let's do that as well. We haven't used the value C yet. That's where the foci are going to come into play. They're going to come into play using this value of C. Now, the foci are always going to be distributed along the major axis between the center and each vertex. So you'll find that when you graph the foci, they're going to be inside of your ellipse between the center and each of the 2 vertices. And they're going to be C units away. So you can essentially follow the model for how we found the vertices. We transitioned from the initial X value a certain number of units, and then that took us to the 2 points we wanted to graph. In this case, we're moving 4 units away from the original center horizontally. So starting at x equals 3, we are moving 4 units in the positive and negative direction. And again, we're moving horizontally, so we're changing the x, but we're not changing the y. So that's going to give us the ordered pair, 3 plus 4, which is 7, 7, -4. And then also 3 minus 4, which will be -1, -4. And ultimately, it's optional whether or not we want to put these points on the graph, but just to make sure the numbers make sense in light of the image, let's actually do that. So 7, -4, here's 7, here's -4, and again, I'm going to graph this one pretty small because it's not actually on the graph, it's a point of reference. And then -1, -4 as well. So -1, -4. Now, how do we verify that these points make sense? We're looking for a couple things. Number one, these 2 points should be along the major axis, that segment that's connecting the 2 vertices. And also, just as the vertices were evenly distributed from the center, the foci should be as well. So each of these foci are 4 units away from the center. So that confirms that at least these numbers and these points make sense in light of what we know about elliptical graphs. Once we have all those attributes, we have them on our graph, we're good to go. So now let's talk about how we put this into our Connect Math and ALEKS homework system. So let's switch screens. Okay, here's our problem again. So let's type everything in, let's check all the attributes we have so far. So the center of our ellipse is at 3, -4, and let's check that. Okay, that looks good, so that's a good start. Now vertices, again, we have 2 ordered pairs because we have 2 vertices, and we determined that one of them occurred at 8, -4, and then the other vertex occurred at -2, -4. Let's check those. Okay, those look good as well. Okay, the endpoints of the minor axis, again, those other 2 points that we found on the graph that were distributed vertically away from the center, those were at 3, -1, and 3, -7. Check those. Okay, those are good. And then also our foci. So our foci, we had 2 of them. One was at 7, -4, and the other one was at -1, -4. And let's check it. Okay, so everything is good so far. All of our key attributes seem to be correct. Now we want to put this elliptical graph onto our coordinate plane. So let's preview the grid we have so far. One thing that's important to notice is that on this grid, our scale is a scale of 2. So each of these tick marks on the grid, we're not counting off by 1, we're counting off by 2. So that's going to be important to keep in mind as we place our points. Now, some of our points have coordinates that are odd numbers. So in that case, it may be beneficial to us to actually plot the points in advance and then try to drag and drop the shape. Now the other thing to notice here is that we have some shapes built in. So in order to graph whichever conic section we want to graph, we can use those pre-built shape operations, those shape tools, and then we just drag and drop exactly where we need to be. So we need the elliptical graph, we're going to choose that, and then let's see what it's going to require. So number 1, we want to place our center. So our center is at 3, -4. Now notice they've been kind of nice and they've allowed you to travel halfway between each of the grid lines as well. So halfway between, for instance, 4 and 6 is going to be 5. So if we wanted to graph at 5, we don't actually have to plot a point manually. We can drag it and we can use the grid because we're snapping to locations other than just the regular grid lines. So we need to place our center at 3, -1, 2, 3, 4. So there's our center, click and drop it. Okay, then we need to place one of the vertices. We can choose either one, it doesn't matter. The first vertex we had listed was at 8, -4, so that's going to be right here. Now, the term co-vertex, when you see that term, think of that as endpoint of the minor axis. That's what that term means. So the first minor axis endpoint we found was at 3, -1, which would be right here. So we drop it, and there we go. It graphs our ellipse for us. So again, what did we have to graph? We needed the center, we needed one of the vertices, and we needed one of the minor axis endpoints, and that's sufficient for our homework system. So let's check it, and there we go. It looks like we have a good graph. So what if your graph doesn't end up correct? Well, first off, you know that all the attributes up to this point are correct because we double checked all those attributes before we actually entered them onto the graph. So more than likely, if you've run into a problem, it's possible that maybe you graphed one of the foci instead of the vertices. Maybe you did something like that. That's entirely possible. Maybe you just didn't drag and drop to the correct location on the grid. So those are going to be important things to go back and check in this case if your graph appears to be incorrect, if it marks it incorrect in this situation. But that is graphing an ellipse in the Connect and ALEKS system.